Front page of today's lesson. Ready? Angles to the arc. Angles to the arc. The arc is 180. What's here? 90. That's your first undercover. If you spot angles at the circle, it's automatic right angle. Front page of today's lesson. Okay. We did that over a week ago. Actually, it's almost 2 weeks ago. Lesson 7.2. Here's the last lesson. Darken the edge of that radius. Now, through that point, draw in a tangent. Called tan. Every time I say the word tangent, sing at the same time. Ready? If tangent to a radius, radius, if tangent to a radius, right angle at the edge. Okay. So that's where we're two more today. Ready? Reference booklets, please. Reference booklets right at the top. Above, Mary Had a Little Lamb. Alrighty. I'd like you to physically trace the chord BC. Physically trace the chord BC. Do this now. Guys, leave platypus alone for the moment. It's whatever you want it to be. It's kind of ready. Trace the radius. Now, make your radius at right angle. Make angle 4. If perpendicular, then bisects. If a radius is perpendicular, if perpendicular, then bisects. If perpendicular, then bisects. If perpendicular. That's correct. If, draw in this radius here, you see it bisects. If a radius bisects a chord, then it is perpendicular. That gives you another, yet again, Next undercover right angle, there's one more, and this one's a deep, deep undercover. These are really hard to spot. In a circle, the concept of distance. It's the next page. It's just flip over your reference booklet. It's the very next page. Follow with me, guys. It's not that hard. Yeah, we've been in the reference booklet for 5 minutes. Okay, do you see if circle then right angles? Scroll down. Concept of distance. A segment. Distance is the physical segment from the center of the circle to the center of a chord. That green right there is distance from the center of bisects the chord, and of course it is also perpendicular. I'm in the reference booklet. So the concept of distance bisects a chord and makes a right angle. Now, draw an arrow by distance and write this phrase, from the center. That's code for distance. From the center. Leave the reference book. Now, back. In front of your packet on the right, we're going to do two problems together. Stay right with me. Don't phase out. Ask lots of questions if I lose you. Alrighty, guys. Ready? You're looking here. Step number one. We did two future examples here. We have here, the code for distance is from the center. As I read, I want you to label this diagram. You label. The chords BC is 12. And B. Those chords are 8 units from the center of the circle. I mean, if you put that 8 in the right place. Those chords are 8 from the center. Put an 8 there somewhere? Okay, let's see if you got that 8 in the right place. Remember, from the center is code for distance, so that right from the center, bam. And here, bam, those are both 8. How many of you got those in the right place, at least? You got those in the right place. Okay. Did you also add your right angles and your hatch marks? If not, do it now. It says we want to find all arc measures and angles and the length of the what? Radius. Right now, we don't even have a radius. Come on, everybody draw a radius somewhere. Doesn't matter where. Draw a radius. Draw a radius. Okay. So maybe you just randomly drew your radius like so. Now, the first part is that you end up with a right triangle. So, draw a radius so that you end up with a right triangle. Draw a radius. Because to keep everything in geometry, you always want to start with the right triangle. Just out of curiosity, how many of you swung your radius to D? Raise your hand if you did to D. How many of you went to C? How many of you went to B? Okay, all of those are perfectly fine. Take a close look. What shape do we have now? More importantly, what kind of triangle? Right. Let's pull it out. Whenever you get a right triangle, instantly pull it out. That's 8. That, if 12's in the middle, that means it's the whole thing. So this is going to be 6. I don't know my radius. That's something I want. I'm going to call it X. Do you see what you want to do there? Here's my sentence. Have two sides, neither side preferred. DJ, this came from half of 12. The 8. Okay, watch, buddy. See, that's a radius. What's this? Yes. Right there. Got it. Okay, let's solve. 8 squared plus, obviously, 6 squared equals unknown squared. All right. What's our unknown here? Grand. Did you guys solve for it already? Excellent. What'd you get? Beautiful. Okay, so we know this is a 10. Bring your 10 all the way around. Now, we also want, it says right here, I want arcs and angles. So I'd like you to sweep the 146. If the chords are equal, the arcs are equal. If the chords are equal, no, 12 is the length of the chords. It's not the degrees. You're not there. All right, and then here we want to get angles in the middle. Ready? Measure of a central angle to its arc the same. Do you see how you can get those? All righty, guys. I'm setting the timer for 2 minutes. I want complete silence for this. Ready? I want you to go as far as you possibly can, all by yourself. Notice the sponge there. The sponge. Nice try. Yes, PJ's demonstrating what sarcasm is. Yes. See that right there? 2 minutes by yourself. Find everything you possibly can. I want you working on your own in complete silence. Ready? Go. The only sound I hear is you reading out necessary. Whatever you can do. Whatever you can do. All that. I honestly had no idea you said that. I also didn't like it. I was like, I was actually pretty good. Yeah, you did. Of course. That's why I asked you to come. Let's see how far we got here. Alrighty. This is 13. I'm going to color code this for you. AB is 24, which means this is 12 and 12. You're told that's a radius, so we have a right angle here, and it's bisected. Let's see. How many of you swung around and made a radius, either O to B or O to A? How many of you at least did that? Okay. Then we have a triangle here. Let me pull it out. Okay, that's 13. This is 12. Ready? The blue is we don't know. The blue's not 13. The red was 13. We do, however, have a right angle there. Did anyone solve for the blue, guys? 5 is correct. Let's put a 5 there. Okay. Now, raise your hand if you actually found it, because I'm going to go from easy to tricky. That was the easy one. How did we do that? For those of you who didn't know, we're going to go unknown squared plus, follow with me if you didn't get 5, 12 squared equals 13 squared. Pythagorean theorem yet again. Okay. All right. Just out of curiosity, the bright green. Look, guys, up here. Everybody, right now, find. Absolutely not, guys. Don't assume. That's 13. The blue is 5. That would make this 8. Okay, that makes this 13. What else do I want you to find? Angles. Do you see any degrees there? You got the 90. Ready? Sing with me. Measure of a central angle to its arc. Okay, let's do the pull up. All right, ready? Watch, guys. That's the angle we're going to use. Let's label it theta. This will take us 2 minutes. We'll be done. Yes, there's our opposite, adjacent, hypo. Guys, those of you who are having side conversations, stop, because this is where people get messed up on tests. This is the #1 thing that they forget to use. That is theta. That is my unknown variable for an angle. Now, I have all 3 sides, so I can use any one of these. I could use inverse sine. Opposite over hypo gives me theta. Inverse tangent. Opposite over adjacent gives me theta. Inverse cosine. Adjacent over hypo gives me theta. No, you absolutely do not have to. There's one right now. Use your calculators. Round your degrees to the nearest whole number. Go. Round your whole number. I personally will always do sine. Yes, yes. I just. Hence, we always need an internal savior, right? That's a good thing. Well, the fact that we have a savior, not that we sin. You guys see how we get that? If this is 67, out here this is 67. Ready? Last one. Find me the blues. Go. got 25 minutes to finish now, pages 4 through 8. 25, actually 35. I am. I'm recording right now. Where'd it go? There it is.